Hello everyone, welcome to this video. I hope you're all doing great. And I hope you have been watching the Algebra video series for the preparation of Indian Statistical Institute or Chennai Mathematical Institute entrance preparation. I hope you're taking it seriously, man. Yeah. And in between, when I show you the promotion of the batch, it's not for fun, it's really going to be useful for you. Yeah, because it's a very well planned batch, and I hope you realize what efforts it takes behind it before you judge the batch just by its promotion. So just think about it and just watch through it. What is the content being provided and everything. Watch the promotion carefully about the batch. Learn about the batch. I'm using the word promotion a lot, but it's about the batch. It's the knowledge of the batch. So have it and then decide properly. Okay, think about it carefully. Now, I hope even if you're preparing on your own, this video series will be helpful enough in terms of how you can decide whether my preparation is on par or not. So, one question at the last will be given as homework, all right, as usual. And we'll have two single correct questions, we'll have two multiple option correct questions, and two subjective questions. One of them would be homework. Maybe I'll give you some hint of something. So that's how we're going to do it. All right. So without much delay of time, let's just begin with today's session. So first question. For real numbers ABC, the value of the determinant this. So matrices and determinants, just to mention briefly, um, is a topic which comes up in 11th and 12th of JEE syllabus. If you're preparing for JEE, or in general, if you're in boards, then it comes in 11th and 12th. Um, so you be very careful. Just use the properties of determinants. I hope you know that you can do C1 if you do this linear operations on the columns or rows or in general the columns and rows. Multiple operations you can do, plus minus. You cannot multiply, you can just add linear operations you can do. If you do that, the determinant value remains the same. So we will use that many times during this session, during this particular video. So what is the thing? So here I'll do C1 equal to C1 plus C2 plus C3. So that's column 1. So that becomes A plus B plus C, A plus B plus C, A plus B plus C. Okay. B, C, C, A, A. That's it. All right. Now here I can take. So if one row is same, if one row has a common factor, you can take that out as a whole for the whole determinant. So this will be equal to A plus B plus C into determinant 1, 1, 1, B, C, C, A. B. All right. Now what I'll do R1 goes to R1 minus R2 because if I do minus, I'll have a 0, and I'll also have maybe I won't do this. Maybe I will do something different. I want two zeros, so R2 will be R2 minus R1. R3 will be R3 minus R1. So this will become two operations I'll do. So A plus B plus C times. So first row is not changing. So 1BC. Second row will be second row minus the first row. So that would be 0, C minus B, A minus C. Third row will be third row minus the first row again. So it will be 0, A minus B, B minus C. All right. So the moment you have this, I think now if you expand through the first column, you will have A plus B plus C into C minus B into B minus C, C minus B into B minus C. I hope you know how to expand a 3 cross 3 determinant minus A minus B into C. So this will be equal to, this is minus b minus c whole square, that is a plus b plus c is equal to minus b square plus 2bc minus c square minus a square plus ac plus ab and minus bc. All right, so what do we have exactly? 2bc minus bc, ac, ab. Ah, this is so good. So this is a plus b plus c um, plus a into ab plus bc plus ca minus a square minus b square minus c square. So if you recognize it, this is a very famous identity which gives you minus of, I think this there is a negative, minus of a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca is equal to minus of a cube plus b cube plus c cube minus 3abc. So overall, this is simply 3abc minus a cube minus b cube minus c cube. I think one of the options had this. So 3abc is the first option. So, I hope it is clear. I think if you have done basic amount of determinants, this question should be very, very straightforward. It's very obvious question. All right. This is again a test of your knowledge, this question. Test of your knowledge about determinants. What do you know about determinants? What do you know about adjoint matrices and all that? So what do you know about scalar multiplication and the determinant of it? So all of these things. All right. Pause the video and try it. By the time I end this, it will take time. So I'll start now. Think about it. Adjoint of any matrix. Let's say M is a matrix. N cross N doesn't matter. Adjoint. Adjoint of M is a matrix which has this property. So M into adjoint M is equal to adjoint M into M is equal to determinant of M into IN. That is the property. Okay, for any M cross M, I'm just telling you this is the property. Now, what do we do? So that will mean that determinant. By the way, determinant has this property of it is a multiplicative operation. So what does that mean? So determinant into M into adjoint M is equal to determinant of M into determinant of adjoint. And that will be equal to the right hand side. So that will be determinant of M times determinant of M times IN. Yes. So determinant, and you should know this thing, determinant of a scalar multiple into any matrix is equal to k power n, n being the order, into determinant of it. Here in this case, this is a scalar, this is a scalar, and this is a matrix. So this will become equal to determinant of m power n into determinant of I. This is anyways equal to 1. So you will have determinant of m into determinant of adjoint matrix of m is equal to determinant of m power n. So determinant of adjoint matrix of m is equal to determinant of m power n. So in case of our 3 cross 3 matrix, our m, in case of our question, our m is 2a. That will imply determinant of m is equal to 2 cube a, and our m is 2a and n is equal to 3. That is also there, obviously. 2 cube into determinant of a, and that will imply determinant of adjoint of 2A is equal to determinant of 2A power n minus 1, which is 3 minus 1, which is 2 basically. And that is equal to 2 cube into determinant of A whole square. So that will be equal to 2 power 6 determinant of A square. So what do we have here? We have determinant of A is equal to 4. So this is simply 2 power 6 into 2 power, so 4 is 2 square whole square, so 2 power 4, 2 power 10. So we know 2 power 10, that is 1024. Yes. So this is the second question. We are done with that. Hooray. Okay. So I hope you're enjoying the teaching style, man. You're not commenting anything. Just please, for my sake, or just for my understanding, can you please comment how it's going actually, how you're actually feeling about this series of videos? Yeah. So let A be a 3 cross 3 real matrix satisfying A transpose equal to minus A. You know what these kind of matrices are called? These are called skew-symmetric matrices. Skew-symmetric. All right. Skew-symmetric. So A transpose is equal to minus A. And by the way, this question has can have multiple options, correct? Huh? Every diagonal entry of A is 0. Look at it. What is A transpose? Let's say A is equal to something. I'm going to take 2 cross 2 A, B, C, D. Then A transpose will be equal to A, C, B, D. Right? And if this is equal to minus A, this will imply minus A is equal to minus A minus B minus C minus D. Uh, this is equal to minus A minus B minus C minus D. And you'll see that when you transpose, in transpose, diagonal entry remain stationary. That means they don't change. The diagonal entry AD is the same as diagonal entry AD in A also. That the same thing will happen in any n cross n matrix. All right. I'm only talking about square matrices, obviously, right? N cross n matrices. So that will imply the diagonal entries D1, D2, D3 will be D1, D2, D3. This transpose will also have D1, D2, D3. All right, the diagonal entries will be the same. Here the things will change. Here the things will change. I'm not talking about that. Now this is equal to minus D1, minus D2, minus D3. Right? So that will imply obviously that D1 equal to D2 equal to D3 equal to 0. This is what is happening. All right, so every diagonal entry is 0, definitely true. Hmm? Determinant of A is 0. Obviously, if diagonals are 0, the diagonal entry is 0. We have, okay, forget the diagonal entry is 0. Just simply determinant of A transpose. We know that this should be equal to determinant of A because transpose doesn't change the um, like if you're opening with column, you can open with row and it will be the same. The determinant will be the same. All right. And that will imply that determinant of A transpose is equal to determinant of minus A as well. And what is minus A? That is minus 1 cube determinant of A. So this will imply minus determinant of A is equal to determinant of A. So that will imply determinant of A is equal to 0. That's it. So option B is also correct. No problem. A square is symmetric. So one thing you need to know, A square whole transpose is same as A transpose whole square. Why is that? Because we know AB whole transpose is B transpose A transpose, right? So A into A whole transpose is equal to A transpose A transpose. So this is A transpose square. Now we know A transpose is minus A, so minus A squared that happens to be A square itself. So yeah, that happens. That definitely happens in. So A square whole transpose is this, and the moment you have this is symmetry. All right. I hope that is making sense. A has an inverse, obviously not true. A cannot have an inverse if determinant is zero, right? Because inverse has this idea. A inverse is what? 1 by det A into adjoint of A, right? So if det A is not here, det A has to be non-zero. Skew-symmetric matrix is never invertible. Understood? So only A, B, C are correct in this question. Let's move on. Look at this question. What do we do? Let's try it out. Okay. So let's continue. Um, let A and B be n cross n real matrices, right? And there is nothing else given about it. So we know one thing, that determinant of AB is equal to determinant of A into determinant of B. These two are, this is a multiplication of real numbers. So you can make them commutative. So that will be determinant of B times determinant of A. This is commutative. So that will imply determinant of this can be written as determinant of B. These two are equal. It's no problem. Okay. If A and B are symmetric, by symmetric what do you mean? By symmetric we mean A transpose is equal to A and B transpose is equal to. This is the definition of symmetric matrix. Then AB is symmetric. Is that true? So what is AB transpose is equal to B transpose A transpose, and that is equal to BA, because B transpose is B, A transpose is A. But is this equal to AB? Is this equal to AB? This is a question mark. Well, A and B may not be commutative, right? That means, suppose I have A as yeah, I shouldn't take unit matrix, so this should be symmetric. And if I take B to be 1 0 0 0, do you see that both are symmetric? If you take transpose, you'll get the same. Okay. And what does that mean? That means, what is AB or what is BA? What is AB in general? Okay. So AB will be 0 0 0 0 0 1 0. Oh, this is not symmetric. This is not symmetric. So that is a proof that this need not be symmetric. This need not be true always. Hmm? Need not be. Okay. So that's what the second option explores, and obviously the second option is wrong. If A and B are symmetric, then AB plus BA is symmetric. Is that true? So just look at it again. Let's try AB plus BA whole transpose. That is equal to um, AB transpose plus BA transpose. So that is equal to B transpose A transpose plus A transpose B transpose. That is equal to BA plus AB. So this is equal to the initial matrix which is inside the transpose. So this means yes, AB plus BA is a symmetric matrix, right? So that is obviously true. C is correct. Determinant of A plus B is equal to determinant A determinant. So determinant is not a linear operation. So one simple test you can do is, if you take A equal to B equal to, just A equal to B, just look at that. if you take b equal to a, so determinant of b plus a will be 2a, that is equal to 2 power n determinant of a. When is this equal to 2 times determinant a? Determinant a plus determinant a. So only when n equal to 1, right? So for n greater than 1 implies determinant of a plus a is not equal to determinant of a plus 2. Okay. So obviously for n equal to n greater than 1, it's not. So for n equal to 1 means it's simply the value itself, so that nothing really changes. Okay. So option D is wrong, by the way. So only A and C are correct in this question. I hope that was fun. Okay. Now prove that this matrix value, how do you calculate this matrix value? So in this question, I'm going to use another property of um, determinants, another property of determinants. That is, if you have column, this is written as column A plus column B, and you have column 2 and column 3, then this can be written as determinant with column A, column 2, column 3, plus determinant of column B, column 2, column 3. So it is determinant is linear if with one of the columns. If one of the columns can be written as a linear thing, then because we are opening up with a column, and if that particular column is written as A plus B or something, so you'll see how I'm going to use that. If you do in this question, if you do C1 is C1 plus C2 plus C3, what do you get again? You'll get 2A plus B plus C, A plus 2B plus C, A plus B plus 2C, right? A, C plus A, B, C, A plus B, right? Now this will imply this is equal to writing it as A plus B plus C plus A plus B plus C plus B, A plus B plus C plus C, A, C plus A, B, C, A plus B. Right? Very good. Now it can be written as a linear in one column. So that is equal to determinant A plus B plus C, A plus B plus C, A plus B plus C, C plus A, B, C, A plus B, plus determinant of A, B, C, C plus A, B, C, A plus B. You see that in the first one, okay, maybe I'll take it as D1, determinant 1, this as determinant 2. In the first one, I can take out A plus B plus C common. So I'll write it as A plus B plus C into determinant 1, 1, 1. A, C plus A, B, C, A plus B. So I'll do two operations obviously again. So R2 will be R2 minus R1. R3 will be R3 minus R. So D1 will be equal to A plus B plus C into 1A R2 minus R1 is 0, C B minus A, R3 minus R1 is 0, C minus A and B, right? So this is equal to A plus B plus C into BC minus B minus A, C minus A, right? So this is first one. So I'll write it as A plus B plus C into BC minus BC plus AB plus AC minus A square. So yeah, done. Is A can be taken common. This can be written as A plus B plus C into B plus C minus A. All right, fine. This is determinant one. This is determinant. What is determinant two? Do I have enough size? I don't. Okay. Determinant two. If you see, I can take the first row A common. So I'll do that very simply. First row A. So I'll take A common. It will be 1, 1, 1. And what will be left of the second two rows? B, C plus A, B. C, C, A plus B. Okay. So B, C plus A, B. C, C, A plus B. How do we calculate this one? I'm so sorry. Yeah. So how do we calculate this one? Now, here I'll do row operation. So row 2 will be row 2 minus row 1. Row 3 will be not row, column. Column 2 will be column 2 minus column 1. Column 3 will be column 3 minus column. So how do we get that? So A 1 B C column 1 is not changed. Column 2 minus column 1 0. C plus A minus B and 0. Okay. 0 0 A plus B minus C. So that is there. So this will be simply A into product of these two, A plus B minus C into A minus B plus C. So you see, this is determinant 2, determinant 1. You know the expression, you add them. I'm skipping this. By the way, this question I was about to give as homework anyway, so I'm running out of slides. I'm so sorry about that. So this is a homework question. Note this down. Come to that later. But till then, let's continue solving this. So we got D1 equal to A into, what was that? A into, if you see, this is A into mm, 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 B plus C square minus A square. No, this is B plus C square minus A square. So let's try that. A into B plus C whole square minus A square. That's it. And D2, we just got to be, if you see this carefully, this is also A into A square minus B minus C whole square. All right. You see this? A square minus, so B minus C, A minus B minus C. So A into A square minus B minus C square. So if you add D1 plus D2, it is simply A into B plus C whole square minus A square plus A square minus B minus C square. So this is A into B plus C whole square minus B minus C square. So that was easy. This is easy to see that this is simply A into B square, and this is simply 4BC, right? So you know. So the overall answer is 4ABC. Yep. So the overall answer is 4ABC. So the question, whatever we wanted to prove, where is it? Yeah, we wanted to prove 4ABC. So now look at this question. This is a linear equation. This is a set of linear equations, and we all know how to solve that, don't we? It's just you can convert it into matrix thing, and if you multiply C in this one and subtract these two, you'll get a term in XY. If you multiply C in this one and subtract these two, you'll get another equation in XY, which is different from the first one. So you can use that and use your idea about linear equations in two variables and solve for X and Y, and similarly you can do for Z very symmetrically. All right, so that's my idea, and now you take it over, and I think you can solve it. It's a very interesting question, very easy question. All the best. Let me know in the comments if you're able to do that, and that's it. Tata. Bye bye.